Hi, everyone. My goal today is to tell you a few things that you probably should know if you're trying to build really AI systems that look at natural language processing, natural language understanding. And let's see if this works. Once you turn it on. No? We'll go with this then. So NLP is really coming to its own in the past, I would say really 2-3 years. And really what happened was that NLP used to really not work as well, right? In the sense that we all knew that there's all these texts we should do things without, but really just didn't, for whatever reason, did not work as well. Some of it was the technology, some of it was what we'll talk about today. But really recently, kind of deep learning happened to computer vision, and then it kind of happened to NLP, and other things came into play in terms of other supporting infrastructure. And now, really in every area of life, we now have systems that actually work, that people use, whether you're in finance, whether you're in the legal space, whether in the news space, in the social media space. And where I've been investing a lot of time in the past few years is really in healthcare and life science, and really look at anything from kind of clinical care, diagnostic care, drug discovery, research, automatic kind of knowledge graph building. Things are doable. Things work, and they work in a fairly consistent way. So you can build things that you can really match or replace a lot of people that are reading radiology reports and pathology reports. So really same things we know how to do with images now, we know how to do with the reports as well, as unstructured and noisy as they are. And what I'd like to talk about are really some of the key things that I've learned and the team has learned as we build those. So one important thing to know about natural language is that, yes, there's all of these advances, but it is a very hard problem. It's actually, this is one of kind of the funny kind of names that people put to these kinds of problems, but it's a wordplay on NP complete, and basically people call natural language understanding an AI complete problem in the sense that if you really solve natural language understanding, I mean, if you can really understand what people are speaking about or writing about, you've solved strong AI. Okay, and this is really because if you think about it, language is the main way we communicate as humans. Okay, when we do other things, we kiss, we play, we do musical instruments, but mostly we speak and we write. And there's a huge amount of nuance and cultural dependencies and context in how we speak. Okay, so if you really understand everything that people say, basically you've solved it. So the important thing to know is that we haven't solved it, right? Obviously, and that's not what we are talking about. What we are talking about is the much more kind of engineering, what can I build today sense of looking at very specific tasks. Okay, and yes, for very specific tasks, we can definitely match or very often improve on human performance. And we can do this in a fairly consistent way. So the goal of this talk is really to give you some lessons learned about what I and the team have learned about building those systems. So in general, we've been doing this for quite a few years now. We do complete projects. Okay, so we take on the data science, the data engineering, as well as kind of the labeling and annotation parts. And we make, we see things through to production, which is usually where you hit, you hit all the snags and issues that you haven't thought about. Because there are, as you know, in everything in software, there are quite a few things that work better until you put them in production. So we've gone through some of those, and here's what you need to know. So the first and most important thing that people often miss is really just this basic fact, and it's not a technology fact, but it's it's just a fact about human language, and that's a fact that really each one of us, we speak many more languages than we realize. And one of the first mistakes that people make when they start working on natural language process, they assume, oh, look, this is an English-only project. Oh, therefore, we should be able to get a lot of things off the shelf. Okay, where often this is just completely misguided. So I'd like to go through some examples of use cases that we've seen to show you really what this means. So here's one example. We're looking at notes within a CRM. And this is specifically a CRM in the commercial real estate business. And the goal is to be able to read through the notes and be able really to understand where the deal is at. Okay, so is this customer or prospect that I'm speaking with, are they just the beginning of the buying cycle? Are they in the middle? Are they almost making a decision? Where do I need an executive kind of to step up and get involved in a deal? Where do I have things at risk? And to do this, really, what we're looking at the nodes. If you look at the nodes, you see things like set up tour, looking for 5 a.m. in the 6 cap range. Here's the 5-year cash flow, some emails that are copy-pasted. Okay, and the first thing to know, and this is very typical when you deal with natural language, most of those sentences are actually just not correct, grammatically correct sentences. Okay, and this actually happens very often. Okay, what this means is that anything you try to apply in terms of part of speech detection, dependency analysis, and everything that depends on those algorithms, name entity recognition, entity normalization, will probably not work very well. The other thing that's important to realize is that really you need to be a domain expert to understand what this means. Okay, so you need to know if someone is just setting up a tour, they're very much at the beginning of working with us. Okay, if someone has asked for the numbers for a specific property, they're more downstream. And if someone is sending you an email about changes to the LOI, okay, then they're far more decided about where they want to go. Okay, but that's something that's obviously very, very specific to this kind of infrastructure. So this kind of problem. So what you will need to know is, okay, we need to first change basically some of the core algorithms and then train models for this specific language. Okay, and then we need to learn specific classifiers that basically tell us what we want to extract from here. A very different example is analysis of academic papers. Okay, so who here has written or read an academic paper in the past? See most? Okay, so one popular thing about other than just enabling search is to look at things like, if I'm in the drug development space, kind of, what level of clinical trial is this thing talking about? Was this a double-blind study, yes or no? Did they publish all of the experiments or only a subset of the experiments? Did they have any conflicts of interest? Okay, can I start mining kind of which proteins, which drugs, which algorithms are being used? And if you read an academic paper, then first of all, mostly they use proper English, right? Because they're professionally edited, they're copyrighted, the grammar is correct. But what you need to know is, for example, that the title usually is keyword heavy, and there's lots of wordplay. The abstract is really the most important thing, right? Because the abstract of an academic paper is the summary of a paper that someone wrote, right? So kind of if you read one thing, that will tell you everything you need to know. You'd probably want to know that the introduction and kind of past research or background research are probably the least important pieces if you want to understand what this study is actually about, right? And then the next sections will tell you more. Okay, so this is another example where basically this has a different grammar, a different vocabulary, and also you really need to understand the structure in order to extract anything useful here. In a completely different example, there's a lot of work on messaging, social media, and this is one example, but it's fairly typical. What happens when you look at messaging or these kind of informal discussions between people? First of all, you definitely don't have complete sentences. The other thing that people do is they break sentences into multiple parts of the conversation, right? So I write something, I press send, I write something else. Obviously, I don't need to tell you who is speaking and who is answering, because it's just implied in the conversation. The other thing that happens here, we have emojis. And if you're thinking about sentiment analysis, like emojis is a language whose only purpose is sentiment analysis. Right? I tell you something, and then I tell you how I think about it separately, which is really something that you need to understand if you want to be able to see, if people are, what are people doing, right? So if what I'm trying to extract is, okay, what did they actually say? Are we going to meet? What do I think about her? Is there a next action here, right? And trying to extract recommendations from it. These are things I need to know. Another interesting things with this kind of personal interaction. Basically, the more profanity that you use, it means the closer you are to the person. Okay, that's not the same when you're doing customer service, right? Yes, good to know. But that's kind of important to know about the relationship. So people use nicknames, they use profanity, they use kind of wordplays, and all of that is kind of fundamental if you want to understand anything at all for how this works. The other thing that SMSs have, they have autocorrect. Because there is a certain kind of errors that are classic to text messaging. You have something different if you're doing OCR or if you're doing speech recognition. You'll have a different style of errors that you're going to get. Okay, so for example, if you're doing OCR, we see the loss in the medical space. All of the 15-letter words, they're always correct. Okay, they're never going to be misspelled. okay, because you guess them from a very specific dictionary. But first names and pronouns you get wrong half the time, okay, which would never happen in regular speech. Okay, so really you need to know what the source is, what the context in order to get this right. If you move to a different domain, so this is an example of a legal transcript. And legal transcripts in court are verbatim. Okay, so every time someone says something that's recorded, they actually have special marks in the language when someone overspeaks, so speaks over someone. Okay, that's recorded. Okay, and let's say we want to build an application. So let's say we want to automatically read all of these. All of these are public. Because we want to build a database that will tell you, which judges are more strict, more lenient. Okay, which judges favor specific, ages, genders, backgrounds, kinds of types of motions, right? So if I have a specific motion, specific person, really, which judge do I want to go to? If I want to make this public, look at different types of human biases that judges have, that would be good to know. It seems simple, but first of all, this has its own language. Okay, especially just the fact that we say who the speakers are. Okay, so it's just a different grammar to do that. This is spontaneous speech. Okay, spontaneous speech uses a different vocabulary, different grammar than written language. Okay, they're completely different. If you don't believe me, just try, Spacy, NLTK, any of those, and try to run your classic any other part of speech dependency parsing. You see those are what works for one completely breaks for the other. The other thing with the legal language is that if you don't understand the procedure and the motion and what's going on, you're not going to understand anything. Okay, so this is an example. This is, by the way, it's a public example. It's online. It's an anonymized example of someone who wants to throw away evidence in a drug trial. So this is just the motion to suppress evidence. Okay, and therefore there's a process of how it goes, right? Which the judge comes in and they ask for evidence. Someone says something. You can object. You're done here. The other side gets to state their case, and then there's a summary. If you don't know that this is how this motion works, there's no way you're going to understand it, because you will not understand why people say certain things. Okay, and that was one big thing, that you actually need a whole team of lawyers just to understand what's going on here. The other piece here, so when I showed this to a lawyer friend, he looked at it and he had some comments, but his main comment was, oh, this is not a motion to suppress. And I said, what the hell? It says motion to suppress evidence at the top, and this is the motion. This is what he says. But I said, no. See, what's happening here is that someone asked for the motion, but then they presented no evidence. They presented no witnesses. All they wanted was to get the cop who made the arrest to come in and show up. And then there was no other objections, and the judge obviously denied the request. So I said, okay, so what happened here? Oh, what probably happened was the defendant wanted to go on vacation. They just want another 6 weeks of delay. Right, so you ask for this motion, then you have to get the cop and organize it and make it happen. But if your customers expect that level of understanding from you, okay, then really it means that you need to go way beyond the text, right? You need to say, okay, a legal procedure, it's a longer game than the text you're looking at, right? Very often it's not what it says on the cover, and this is what you need to be able to read. The other thing that happens in a legal space, you have lots of boilerplate. Okay, so you have pages of completely meaningless text. This also happens a lot in financial filings. And actually the link here, there's a link here to a tutorial about understanding SEC filings, and that's also something we've worked on a lot. What's interesting about this tutorial is this comes from completely non-technical background and conference. This is a journalist teaching other journalists, okay, how to find interesting nuggets of gold to report in 10Qs and other types of financial statements. Okay, because what happens in financial statements is that I write a 150-page document to hide the fact that I'm adding a new class of voting stock in page 59 because there's a public required disclosure, right? So really you need to learn, okay, how do you look for the things that are interesting and what can you get out of them? And this is also another case where you need to understand the document, you need to understand the context, right? You need to understand why people write, what language they use, so that you can start understanding anything at all from it. Very common. Another example is email. So we've all done emails, but that's another language that if you think about it, you had to learn. Okay, because we had to learn how we do threading, how we do replies, what does it mean, how do you get the sender, and such. The other interesting about email is that this is the actual string you get. Okay, so the text of the email is a very small part of an email you get to analyze. which in practice means that if this is the text you're processing, it's going to be very domain specific, right, to the context, obviously the type of fields, the type of system, so that you can start asking very basic questions. So let's say, for example, I want to build a feature that reads an email, maybe proposes to schedule an appointment, right, to set up a follow-up task if that was what was proposed. It is going to be something that's extremely specific that you need to train for. One last example, I don't know if anyone has ever tried to actually read transcribed sports broadcasting. It makes no sense whatsoever. Other than not using complete sentences, people jump from subject to subject in the middle of a sentence. Okay, so for example, let's say I want to listen to a radio broadcast and automatically just give you a live score on a web page or a mobile app. Okay, that's one thing people want to do. Other things people want to do is analyze kind of player performance, what kind of moves are popular when. Okay, so obviously, I don't know if any one of you has ever built a classifier for goofy comments and local remarks, but that's a classifier that you need to build for those cases. The other thing, very often you have statements that go from subject to subject. Okay, so he's throwing the ball, he's had a great year. And notice how the team tries and now he caught it and points. Okay, so you have kind of 3 or 4 separate facts about separate things that people say within kind of one sentence, spontaneously. And this is obviously specific to a country, this is specific to a type of sports, and often it's specific to a broadcasting channel. Okay, so really, one thing to take from all of this. Those are different languages. Okay, what it means, it means that when it comes down to all of the different algorithms that you need, okay, when you're looking at your own context and your own business problem, the first thing to understand is that there's probably a separate language that you need to train models to understand. Okay, I would go further and say I've been doing this for almost 10 years. I'm yet to see someone being able to just take a model from elsewhere and use it as is. Like, I've yet to see one case where that actually works. In practice, so there are a lot of NLP packages who come with pre-built models. It's very good for pedagogical purposes. It's good for a quick start kind of educational. Here's how you use this. But if you're setting expectations for a model that would actually be accurate and would actually work, the first thing you need to understand is that you probably have an opportunity to learn kind of a nice micro language on its own. And I do call them different languages because usually it is, it's exactly that. It's a different vocabulary. It's a different grammar, it's a different meaning, and it takes time to learn, right? So if I want to learn how to read financial statements or how to read medical reports, it takes years, right? Like you need to learn it, right? You need to do immersion, you need to learn the grammar, right? You have to have people who talk back to you, really, and learning how to read pathology reports can take you as much effort as it would take you to learn Portuguese, and technically you should treat it as such. Okay, so that's the first thing. Now that we've realized that, here's what you actually need to do. And this would seem very obvious, other than the fact that sometimes it just doesn't happen and people start projects. One of the biggest kind of reputation risks with NLP is that people try it and they conclude that it does not work and does not help their specific problem and move away. Okay, mostly because they've applied it incorrectly, right, or try things that really just were not trained on the same problem. So one of the first questions that people ask is, okay, can I just at least start with an off-the-shelf model? And really the simple answer is like, no. I'm just not gonna work for you. But the cool thing is now there's a very easy way to prove it for your own problem. Here are kind of some of the top most popular cloud-based and open source NLP and NLU libraries. And there are definitely other ones. I mostly use one that's not here. But what's nice is that everyone here, except for Amazon Comprehend, actually give you a nice web UI that you can copy and paste text to, and you can actually see the results. Right? So kind of, live, just try our API here, copy paste this, see what happens. And they do sentiment, they do entity resolution, they do language detection, they do emotion detection, they do other things, and you can see it. So this enables you to see really what works and what doesn't. Okay, so that's definitely just an easy way, kind of five-minute test to see what works. So here's one example. So this is fairly typical of what you see in the healthcare space. These are notes from an emergency room. Okay, so these are people coming to the emergency room. Okay, and then someone writes, okay, here's why this person is here, here's what they came. and especially when people change shifts, this is the first thing that people want to read to understand what's going on. So if you look at the first example, a state started last night, upper ABD, took Alka-Seltzer, approximately 0.500, no relief, nausea, no vomiting. Okay, so this is a person in deep pain and deep problems. If you read all of these sentences, first of all, like almost as usual, none of them are valid English sentences. None of them include the word patient. None of them include the word pain, okay, because it's pretty obvious from the context. Okay. The other thing, I showed this to two doctors. Both of them looked and said, oh, this is fine. Okay, like this is exactly what I need when I come to someone. I don't want the whole story. I want to know in 15 seconds what's going on, right? And this actually helps. This has the details I need. There's a lot of abbreviations. So upper ABD is upper abdomen. Approx 0.500, that's presumably that's dosage and not the time of day. 10/10 in the second example is level of pain. Okay, and there's other kind of non-abbreviations for other types of vital signs. So we need someone who can read this very unique grammar when you use like plus nausea to say that someone is nauseated. And really what I want to know, I want to extract features. Okay, so I want to be able to say, okay, this person, can you give me in a structure-coded way, where does it hurt? How much does it hurt? When did it start? What did you already take at home? Right? Ideally as kind of SNOMED code or drug codes, nicely normalized times and dosages, right? So that I can use those features. In our case, it was to predict really whether you are likely to be admitted to the hospital and for how long. Okay? So most of the information is here, right? Human doctors would definitely look at here and give you a reasonable prediction, and we wanted to do that. So to be able to do that, I need to understand the sentences. I need to be able to extract, diagnosis, symptoms, products. So if you copy paste this to all 6 of the engines that you showed in the last page, basically, you get nothing. Okay, so they recognize none of the symptoms, none of the diagnoses, none of the time or dosage or other kind of metrics. 2 of the 6, and I will not say which ones, tell you the Tylenol is a product. Okay, which is good, and that's really the only recognized named entity out of all of this, out of all engines. The other thing, you see all kinds of mistakes really around part of speech and dependency analysis. Okay, dependency parsing, because really those are not normal sentences. Okay, because this is not written in English, this is written in ER doctor speak, right, which is its own thing. Which really goes to show, okay, this probably I just, whatever I get there just doesn't give me anything. So this is an obvious example. Because you can say, look, this is healthcare. Obviously, it has its own dictionaries and ontologies. I need to train of that. We've had a different project where what people wanted to do was do basically a news surveillance for the financial industry. And the goal is to be able to read news and tweets and other kind of bursting news, and be able to know whether a stock is likely to go up and down. Okay? And they already had a time series model and time series forecasting, and they really said, okay, can we, look, we don't need this to be very accurate, because we just hope to add a signal, right? So if we can, for example, look at incoming tweets or news or Reuters or Bloomberg messages, just do sentiment analysis to see if they're positive or negative. So we're going to see if we can add it as a signal, right? And then when our quants go and train the time series forecasting model, basically, if it helps, there's going to be a lift, some lift in accuracy to the model, at least that's what we hope. And in that case, they started with Watson, because Watson has actually pretty comprehensive emotion analysis kind of cloud service. And they worked on this for a few months, and they got no lift whatsoever. Okay, and that's often where NLP projects stop, when they come and say, okay, look, we've been doing this for 5 months, we tried every version of the API, and it just doesn't matter. It just doesn't help. Right? We just have our models, and they're based on time of day and time of week and kind of a rolling average, and this just doesn't give us any lift whatsoever. Okay, but the problem, of course, is not kind of in the fundamental, because there is information there. Right? And obviously, people read it and make decisions based on it, so there's obviously some signal there. The problem is really the classic problem that you have with cloud providers, which is the fact that you are using a pre-trained model. Okay, so if you're looking at sentiment analysis models, the usual ones that you get, mostly they're trained for a kind of customer service issues. And then the strongest signals are usually emotion words. Okay, so if someone is extremely unhappy, right? And they voice that fact, right? So I'm extremely happy. They tell you, right? And those are the strongest signals. If you look at financial reporting, they do not use emotion words. Okay? They're not going to tell you, I'm extremely upset, and this is the lousiest, effing stock I've ever seen, blah, blah, and therefore I'm going to sell it. No, they're going to say something like Citron short TWTR, right? So in general, you're going to have very simple statements. They're going to be very neutral. Okay, and the other thing that's important, it's not about what they say. Okay, because if I'm going to tweet this, nothing's going to happen. Right? It's about who says it and what the reputation is. Okay, and those are really the signals. Okay, and it's actually pretty funny. So the top one, the Square app, it actually gained, it was something like, I think, just under 10% in one day, because some analysts said that in July, they had more transactions than Venmo. Okay, and I kind of looked into it, and it really was just one analyst. So Square did not say it, Venmo did not say it, there was no data. Right? Just someone really just tweeted it and kind of it caught because of who that person is. Okay, so what you need to know is you need to come say, fine, we understand that you're looking for sentiment, but sentiment in the financial trading space is very different than sentiment, right, in the customer service space or in another space. Okay, and really once you train a model that looks specifically at those kinds of things, yes, then you start seeing a lift. Okay, because otherwise, yes, you just, you're running a model, you're running inference on a model that was trained on something completely different, the features are not there, and you're not getting anything. Okay, so this definitely happens also in cases where you come and say, look, I don't care if it's inaccurate, I'll just see what I can get. Very often you'll get very little. So you don't need to train your own models, okay, basically for every problem. The other thing you need to be able to do is make sure that that your labeling is right. Okay, and this also happens in every problem. So sure, if I'm looking at radiology reports, I want a radiologist to come and say, okay, what kind of diagnosis this is. But look for example this example. So this is an actual Yelp review of a restaurant. So let's do a test. Who here thinks this is a 3-star review? Who thinks this is a 4-star review? Who thinks this is a 5-star review? 2 stars? 1 star? Okay. So my point was not to show where the the kind of median or mode will be. It was just to show that there's a variety. Okay, and the problem is, people look at this and say, oh, this like anyone can do this. Okay, and the challenge with anyone can do this is that you give it to people and say kind of, oh, you just use your best judgment. And then what you get labeled data sets that have 50 or 60% agreement between judges. Okay, and when that happens, so let's say, for example, and this happens when you're doing reviews, this happens when you're doing search rankings, this happens when you're doing relevance ranking for things like music, restaurant, dating, but also this happens a lot in the finance space. So everything regarding fraud detection or anomaly detection, like is this real? Would you follow up and check on this, yes or no? Okay, and the problem is if you have 15 judges, but between them they have a 60% agreement rate, then 60% is the theoretical upper limit of what your accuracy can be. Okay, so like if you match the data set at 80%, by definition you're overfitting, right? Because I just send the same data set to the same people, okay, and I will get different results. Okay, so one of the most important things is really make sure that actually your label data and the guidelines are actually accurate, which is hard to do in language. Okay, it's much easier to do when you're looking at numbers, but language really, there's a lot of things that are just fundamentally personal, right? So what I think is a good restaurant, a good movie, a good date, a good song, right? It's going to be very personal to me. This is one recent project we had where we're looking at pathology reports. And pathology reports, that's supposed to be really cut and dry. You get a one-pager, and the goal to come and say, is there a tumor? Sorry. Is there a tumor? What size is the tumor? What laterality? What is the grading? And we were not as surprised at that point. Definitely our clients were surprised to know that half of the time and the effort of the project was really just a small team of doctors, oncologists, pathologists, arguing out and ending with a 16-page document. Can we say, okay, how are we actually going to label this? Okay, because there's a lot of active debate on what do you do when you have two tumors, so which one is the primary, how do you decide the location, how do you decide the grading? The grading, it's different for different types of cancer. And all of these, they're actually important. Okay, so if you are an oncologist, these are not, these are not like off-the-side things that you can spend time arguing. This really is important when you treat people. And that was really most of the project. So of course, we do a whole lot of work on deep learning, on reinforcement learning, on optimizing different neural networks. But more often than not, this is where your project succeeds or fail. Okay, and this is also where you add value. Does anyone know what these are? Two precedents. So these two legal precedents, this is the foundation of the e-discovery industry. These are the two most well-known precedents where judges actually allowed people to, when you need to turn over results to the other side, you can actually only send the documents that come up in a search engine instead of sending them everything. Okay, so the question was, okay, how can you actually make sure that you're not hiding things by selecting the keywords or basically how does this search functionality supposed to work? And this is another example where, yes, like sometimes you need domain experts. And in this case, yes, if you think about the industry, you should have a team of judges and lawyers argue for a whole lot of time on very specific documents to decide on very specific guidelines, right? And this should not be kind of an engineering decision on what you do. And in quite a few industries, that's a level you should go to and you don't, and really should consider how that fits what you're doing. So this is the next, most common questions after why can't I just use off the shelf stuff? How much label data do you actually need for a project? And the answer is, of course, it depends. Not only it depends, like if someone gives you a number that's already wrong, okay? No, it's the same. No, if you ask someone, how much should I pay for a house? Like if someone just tells you $200,000, that's already wrong, right? Because it obviously depends on your personal situation, on what you need and where you are and your life and all of that, right? So same thing here. So the first thing you need to do is actually get representative data, right? So are you actually representing all the classes in a correct way? Okay, and sometimes you need 10,000 examples, sometimes you need 10 million. The other thing that's really important is get consistent labels, okay, from people who actually speak the language you are trying to understand. And the third thing you need is you don't only need, you need more than labels. Usually you need ontologies, you need dictionaries, you need word embeddings. Those have to be domain specific as well. And that's the other thing you need to make sure you get. Okay, and that's usually so what happens today is that doing deep learning, doing reinforcement learning at scale, that's actually the easier part. This is where you build a lot of the IP and you spend a lot of the effort. Okay, one last thing when you're starting a project. So we're talking a lot about NLP project. There's actually no such thing as an NLP project. There's a machine learning project or an AI project where some of your features come from unstructured data. Okay, and that's really where you want to start. Okay, so there should not be an issue of, okay, do I only use language? How do I use the other structured features? You always use them and you always combine it. Okay, so if we look at the example we had before, so we're looking to to predict demand for hospital beds and hospital nurses. Okay, usually what you do is you start with the structured data. So I'm sitting in the ER, what's my age, what's my insurance, what's my medical code, right? What are the codes for the drugs I filled in? What's the day of the week, right? So people tend to stay longer on weekdays for whatever reason. Okay, and you do want to start with that. Okay, if you're doing financial forecasting, start with your classic time series. On top of it, you start adding unstructured features. So a typical NLP pipeline means you have a machine learning problem. You use all of the NLP algorithms to generate additional features, right? And then you go back to basically your feature engineering, building, training, and optimizing models. Okay, and that's the only way you should work. It's one very well-known example that's kind of becoming a standard in the medical space on detecting sepsis. So sepsis is a severe infection that kills people in hospitals, quite a few of them. So being able to predict sepsis is a widely studied problem. This is one published example from last year, where basically, by adding clinical features from unstructured text, they were able to get an increase in AUC from 0.67 to 0.86, which, if you're familiar in this space, really means it's going from useless to state-of-the-art. Okay, so anything below 0.7 you do not use. Anything above 0.8 you check for overfitting, right? Because it's almost too good. And here they were able to get to fantastic results. The reason they got a fantastic result, and this is very important to know, is because in the healthcare space, most of the data is in the notes, right? So if you ask a human doctor, what do you need to read to make a decision, they're not going to tell you, oh, I'm on the list of medications or I'm on the list of vital signs. So what did the previous doctor wrote? Like, why this person here? Right? That's the most important thing. Okay, so really it's a question of, okay, do you have the right modeling algorithms to get those signals out? So once you do that, one very important thing you want to do is make sure that you actually unify your NLP pipeline and machine learning pipeline. You are going to get accuracy hits if you, most people just use separate libraries for NLP and ML, which makes it very hard to come and say, oh, can I now replace my tokenizer, replace my part of speech, use a different spelling correction algorithm. But they don't, because those run on separate clusters, separate teams. Okay, so it doesn't actually happen. Make sure it doesn't happen to you. And there's this is one of the libraries, Spark NLP, that I work with, but there's a whole set of libraries that can allow you to do that. And just 2 minutes to summarize. Here's what you need to think about when you take a project. So when you start and you're looking for your first NLP project, look for a project, obviously, that's important to the business, kind of has a good business case. Start with something that sort of works without free text and see if you can improve it. The way you'll know you can improve it, okay, is usually pretty obvious. You'll know you can improve it if really when you ask humans to do it, basically they start with the text. Okay, so you know, when doctors need to understand radiology reports, they read the report. Okay, if you go to a lawyer and you want to ask, what do you think are my chances? Okay, they're not going to say, oh, tell me the judge, tell me the time of day, you have the hearing, right? Tell me the type of hearing, tell me your age, tell me your gender. They're going to say, well, can I read the motion, please? Right? Because that's where the data actually is. Okay, if you're in a customer service situation, right, and someone escalates a complaint to you, right? Your first question, okay, like, what did she say? Right? Can I just read it? Yes, of course, I need to know who's this customer, how long they've been on the phone, are they a gold customer, right? How often do they call us, blah, blah. But like, what do they want? Okay, so look for cases where it's pretty obvious, right? For anyone, kind of your product management to you, that the text has the signals. Okay, and then it's really about just running through the correct kind of engineering data science process to get it. In terms of what you should expect from a project, I would definitely say that today, if you're using kind of state-of-the-art deep learning, reinforcement learning algorithms, you will beat human performance. Okay, so you will do better than human domain experts. Okay, and by domain expert, I don't mean people off the streets. I mean the people who have already been doing this for 10 years. I would not have said this a year ago, but like I say, like we've had kind of 6, 7 projects this year, and it feels like, yes, we can consistently get to this result. And for us, really, it's a combination of software, but we also we do the whole project, so we know that all the steps are done correctly. But it's definitely what you should expect. The only caveat is that beating human kind of performance is not that big of a deal. Humans are not actually very good at many things. And one of the mistakes people come and say, it's like, now we can automatically diagnose patients for clinical disease, where it's like, no, we're actually only at 80%. And people say, well, what do you mean you're completely wrong for 1 of 5 patients? And the answer is like, that currently what's happening in the hospital is, getting 50%, right? Because that's what, that's the best that humans do. And by humans, we mean people who've been doing this for 20 years after school. So that's very common. But really, kind of when you set expectations, people do still expect magic from AI and from computers in general, because people are used to the pre-AI days when you automate. If I build a calculator, right, the calculator is never wrong, right? You just ask and it gives the correct result. It's not a sometimes maybe. But of course, we are in the ML and AI space, so we are much more just learning, for example, and seeing what works. So those are the only thing I would say around expectation setting. So those are the 3 things we spoke about. Other than that, my contact details are there. Honestly, I'm just curious to meet people and see what people are doing, what works, what doesn't, because all of this is a very new space. I would say every year for the past few years, they've been, I've met people and they've done like real new things that I was able to learn from. So I'd be happy to connect. Thank you.